Assalamu alaikum, dear students. Welcome to all of you in Network Professionals, the Cisco Networking Academy, and I am your instructor, Ahmed Malik.
Hey dear students, welcome to all of you in the fresh lecture of Introduction to Network. In our previous lecture, we discussed about network components like host and client devices like server or client. We also discussed about different types of networks like peer-to-peer network and server client model. And most importantly, we discuss about different types of devices like end devices and intermediately or networking devices, and also discuss about some security devices. And in the last of the previous lecture, we discuss about network media, and we discuss about different types of medium and media. We discuss about copper and fiber optic cable and some wireless media type. In our today's lecture, we are going to discuss about network representation and topology diagram. Network diagrams, often called topology diagrams, use symbols to represent devices within the network. Network architects and administrators must be able to show what their networks will look like. They need to be able to easily see which component connects to other components, where they will be located, and how they will be connected to each other. Diagrams of networks often use symbols like those shown in the figure, a representation of different devices and connections that make up a network. In the figure, you can see that we have shown you some end devices, intermediate devices, and cables. All these symbols are the main parts of our topology diagram. The diagram provides an easy way to understand how devices connect in a large network. This type of picture of a network is shown as a topology diagram. Ability to recognize the logical representation of the physical networking components is critical to being able to visualize organization and operation of a network. In addition to these representations, specialized terminology is used to describe how each of these devices and media connects to each other. Those are network interface cards, NIC, physical port, and interface. Network interface card is a physically connects the end device to the network. Physical port, a connector or outlet on a networking device, on a router or switch, where the media connects to an end device or another networking device. Interface is a specialized port on a networking device that connect to individual networks, because the internet is a network of networks that connect hundreds of millions of computers worldwide. Network representation or topology diagram. Topology or topology diagrams are divided into two main categories: physical topologies and logical topologies. Physical topology diagrams illustrate the physical location of intermediary devices, like where your router, switches, PCs are placed and connected. On the other hand, logical topology diagrams illustrate devices, ports, and most importantly, addressing scheme of the networks. Topology diagrams are mandatory documentation for anyone working with a network. They provide a visual map of how the network is connected. There are two types of topology diagrams as shown in the figure. Physical topology diagrams illustrate the physical location of the intermediary devices and cable illustration as shown in the figure. You can see that the room in which these devices are located and labeled in this physical topology. On the left side, you can see that in a physical topology, our network has divided into 6 different rooms where different devices are connected with each other, in which racks they are placed, and how they are connected with each other. But you are not able to see on which interface the cable is actually connected and on which interface which IP is working or which IP scheme we are using in this topology. But on the right side, there is a logical topology. Logical topology diagram illustrates devices, ports, and addressing scheme of the network as shown in the figure. You can see which end device are connected to which intermediate devices and what media is being used. The topology shows in the physical and logical diagrams are appropriate for your level of understanding at this point in this course. You can search the internet for network topology diagram to see some more complex examples. And if you add the word Cisco to your search page, you will find many topologies using icons that are similar to what you have seen in these figures. And most importantly, you can also practice these topologies by using Cisco's packet tracer, where you can design this topology. And I think you must try to design these topologies in your packet tracer. Common types of networks. Networks are of many sizes. Now that you are familiar with components that make up networks and their representations in physical and logical topologies, you are ready to learn about the many different types of networks. Here you can see in this picture, there are 4 main types of networks: small home network, small office, home office network, medium or large scale network, and worldwide networks. Network comes in all sizes. They range from simple network consisting of 2 computers to networks connecting billions of devices. Simple home networks let you share resources such as printer, documents, pictures, and music among a few local devices with single internet connection. Small office and home office networks allow people to work from home or a remote office. Many self-employed workers use these types of networks to advertise and sell products, order supplies, and communicate with customers. Business and large-scale organizations use networks to provide consolidation, storage, and access to information on network services. Network providers email, instant messaging, and collaboration among employees. Many organizations use their networks to connect to internet to provide products and services to the customer. The internet is the largest network in existence. In fact, the term internet means a network of networks. It is a collection of interconnected private and public networks. In small businesses and homes, many computers function as both the servers and clients on the network. This type of network is called a peer-to-peer network. Network infrastructures vary greatly in terms of size of area covered, number of users connected, number of types of services available, and area of responsibility. The 2 most common types of network infrastructures are local area networks, known as LANs, and wide area networks known as WANs. A LAN is a network infrastructure that provides access to the users and end devices in a small geographical area. A LAN is typically used in a department within an enterprise, a home, or a small business network. A WAN is a network infrastructure that provides access to other networks over a wide geographical area, which is typically owned and managed by a large corporation or a telecommunication service provider like SPs or service provider. In this picture, you can see that our three different LAN or local area networks are connected with each other through wide area network, which is also known as internet cloud. Here you can see that we are going to discuss in detail about LANs and WAN. A LAN is a network infrastructure that spans a small geographical area, while a WAN is a network infrastructure that spans a wide geographical area. LANs have specific characteristics. LAN interconnects end devices in a limited area, such as home, school, office building, or campus. A LAN is usually administered by a single organization or an individual. Administrative control is enforced at network level and governs the security and access control policies. LANs provide high-speed bandwidth to internal end devices and intermediate devices as shown in the figure. Normally, you can say that LAN is very high speed and low cost. Wide area networks are used to interconnect different local area networks with each other as shown in the picture. Here you can see that our branch 1 local area network 1 and branch 2, which is another local area network, these are interconnected with each other through two routers, and the red sign of cable shows that they are connected through a wide area network or WAN link. WAN have specific characteristics. WANs interconnect LANs over wide geographical areas such as between cities, states, provinces, countries, or continents. WANs are usually administered by multiple service providers. WANs typically provide slower speed links between LANs. The figure shows two branch LANs connected via a WAN link. Both LANs are highlighted in a yellow box and consist of central switch connected to three PCs, an IP phone, a server, and a router. The two routers are connected via a red WAN link. On the left is the branch 1, which is the LAN 1, and on the right is the branch 2, which is the LAN 2. The internet. The internet is a worldwide collection of interconnected LANs and WANs. The internet is a worldwide collection of interconnected networks, internetworks, or also known as internet in short. The figure shows one way of view to the internet as a collection of interconnected LANs and WANs. Here in this picture, you can see that 5 multi-layer switches with redundant links are shown inside a large internet cloud. Around the edge of the cloud are several routers which are connected with these switches, and through these switches, multiple local area networks or LANs are connected in this network. Some of the LAN examples are connected to each other through a WAN connection. WANs are then connected to each other. The red WAN connections or lines represents all the varieties of ways through which we can connect our networks with each other. WANs can connect through copper wires, fiber optic cables, and wireless transmission. The internet is not owned by any individual or a group. Ensuring effective communication across this diverse infrastructure requires the application of consistent and commonly recognized technologies and standards, as well as the cooperation of many network administration or agencies. There are many different organizations that were developed to help or maintain the infrastructure and standardization of internet protocols and processes. These are non-profit organizations. These organizations include the Internet Engineering Task Force IETF, Internet Corporation for Assigned Names and Numbers ITN, and the Internet Architecture Board IAB, and many more such organizations are available which are maintaining our today's large-scale internet. Some other common types of internet are intranet and externet. Internet is a term often used to refer to a private collection of LANs and WANs that belongs to an organization. An intranet is designed to accessible only by the organization's members, employees, or others with that organization, or some other people with authorization. An organization may use an extranet to provide secure and safe access to the individuals or groups who work for different organizations but requires access to the organization's data with authorization. Here are some examples of extranets, like a company that is providing access to outsiders or suppliers and contractors. Another example is a hospital that is providing a booking system to doctors so that they can make appointments for their patients, and a local office of education that is providing budget and personal information to the school in its different areas or districts. The figure also illustrates the different levels of access that different groups have to a company intranet, a company extranet, and the internet.
That's enough for today, and stay connected for all upcoming videos. Thank you very much.